So in the start of the session, we discuss few things about the syllabus. So there are total 6 sections. So the first topic or the first section that we completed from those 6 is thermal physics, right? So we are done with this topic, thermal physics. Now we are going to start a new section, that is nuclear physics, right? This section is also short. So in new term, like in second bi-monthly, we are going to complete this nuclear physics topic. Okay. This is also simple. This is also short topic, just like thermal, or we can say it is more short than the thermal. So
Sir, we have done thermal physics and we'll be starting nuclear physics.
yes, and nuclear physics is completely a new section, right? This is the second section. So this is our section number 2. Like according to our syllabus of school, this is our section number 2, nuclear physics. And for this topic, for nuclear physics, you don't need to like revise the whole chapter of the thermal physics, because nuclear physics is a completely different concept. So it is not compulsory to revise or like learn all the things from the thermal physics. So nuclear is completely a different topic. And the concept of nuclear physics is like the starting topic of the nuclear physics is more related to the chemistry also. Just like in chemistry, you discussed or you studied about the concept of atoms, right? The structure of an atom, the proton, electron, nucleus, maybe you studied in the chemistry also. So the first chapter or the first topic of the nuclear physics is related to that part. So there are basically 2 chapters in this nuclear physics section. The first one is atomic structure. Atomic structure of an atom, or in short, atomic structure. And
Sir, section 2 can also be given the name as chapter 2.
yes, you can also say like a complete chapter 2 of nuclear physics, right? Just like first one is thermal,
Okay.
and there are 3 different chapters in thermal, just like we have a second topic, nuclear physics, and there are 2 chapters in nuclear
Yeah,
physics.
sir, there so we could say
Subtopics,
thermal physics was a chapter and the subtopics or the lessons
yes.
were 3.
Yes.
Okay, thank you.
Because these chapters, are linked with each other. So it's up to you that how you like going to write down the name, either the topic, either the chapter. That is not important. We have to complete a whole syllabus, right? Okay, so in nuclear physics, there are some basic concepts which is related to the atomic structure, just like we discuss about solid, liquid, and gases. But this time we have to study about the basic or like micro level knowledge about the atom, like what are the other particles, just like proton, electron, neutrons. In previous chapter, we only discuss about solid, liquid, gas, right? Like macro level. But now we are going to discuss about the micro level, right? About proton, neutron, electron. We know that we are not able to see or observe proton, electron by our normal eye. So that's why these are microscopic particles or the fundamental particles. So the first thing that we have to discuss is about structure of atom. So how many of you already know about structure of an atom? If anyone wants to share idea about structure of an atom. Okay. Okay, no issue if nobody have like the concept of the structure of an atom. Structure of an atom is very simple. Yes.
I was saying about telling about the structure of an atom, but you're telling it's okay.
No, no. If you want to share, you may share. No issue.
No, sir, it's okay. You can say.
Okay. Basically, like in our schools, like in grade 6, 7, 8, we study in science about the structure of an atom, and we know there is a nucleus in the center, and electrons are revolving around it. And this topic is also the part of chemistry syllabus also. So that's why this topic is very easy because you are going to study the same topic in the both subjects. So it will be easy for you. So in structure of an atom, there are subatomic particles. Just like we are talking about subtopics, so in the same way, there are subatomic particles. And in subatomic particles, we have three different particles. The first one is proton, electron, and neutron. Any idea about proton? Like what is the nature of proton, how it looks like, or what are the property of proton?
Sir, they are positively charged.
Okay. Anyone else?
Proton and neutrons, when they are put together, they form a nucleus.
They form a nucleus. Good. So you mentioned they are positively charged. That is absolutely fine. And you mentioned that when we combine them, so they forms the nucleus of an atom. Or any other information, if anyone wants to share.
Uh, neutrons are like negatively charged.
Neutrons are
They're,
null
they're
charged,
They
neutral.
have no charge on it. They
They
are
have no
neutral.
charge. Yeah, they're
and
neutral.
electrons are negatively charged, which are present in the shell or the orbits of the atom.
Okay. Okay. So Alhamdulillah, you all know about very much for the structure of an atom, and you already mentioned some things. First of all, if we talk about the proton, so definitely you are correct that proton are positively charged particles. Positively charged particle. Okay, I'm writing with the symbol, but in your exam, you need to write incomplete words positively. I'm just writing in the short form. But when we are going to solve the questions, so we will write complete positively, right? So proton is positively charged, electron is negatively charged. You all know about it. Just like the example of the cell and battery, in cell or battery, we know that one side is positive, other side is negative. And neutron is neutral, right? By name neutron, it is neutral. It means no charge. Right? So I'm writing no charge. You can also write neutral, right? Neutral means not positive, not negative. Okay. And the second thing you mentioned that proton, electron are making up the nucleus of an atom. So
No, sir.
basically,
Proton and neutron.
proton
Electrons are
revolving around it. Okay.
electron is revolving around the nucleus in the orbit of the shells.
Okay, okay. Right. So before writing down the structure of an atom, there is something that we have to discuss before that. As you already know about the structure of an atom, but before, like when scientists are working on it and they are going like try to discover what is actually atoms looks like, what is the structure of an atom, and how to like discover the things. So during their discovery, they propose different models like plum pudding model, but that is not in our syllabus. Maybe in chemistry you will study that part. So they propose different model, but from those models, uh, the one model that is proposed by Rutherford, right? So that model
Yes,
is
sir.
helpful, right? And we are using that same model. Okay, so I will show you that model also and the diagram, so it will be easy for you to understand. Nucleus, because that topic is also included in our syllabus of nuclear physics, so we need to know about that part, that what are the supposition of the Rutherford experiment, and how we like come to know that structure of atom is actually look like this. So I have complete picture of it. So basically in Rutherford experiment is also called gold foil experiment. So some of you maybe remember that concept by the gold foil experiment, and some of you know by the name of the Rutherford experiment, right? So
Sir, I know it.
yes, so mostly we studied in like previous primary, secondary science books, so we already know about it. Okay, so you already know about all these things, proton, electron, neutron. We will again discuss that part. But this is the experiment, right? In this experiment, you can see there is a gold foil in the center. So this is a gold foil. Just like the aluminium foil we use in our kitchen, right, to wrap the food. So Rutherford also takes same type of gold foil, right? Just like the aluminium foil. And then we have source of alpha particle. You can see this is the source of alpha particle. And what is alpha particles? In this chapter, we are going to study that part also in detail, what are alpha particle. But right now, just you need to keep in your mind that alpha particles are also positively charged particles, right? These are heavy particles, like heavier than proton. Okay. So these are also positive and they are heavier than proton. Okay. So alpha particles are also positive particles, and you can see many alpha particles are moving towards the gold foil. You can see it is mentioned beam of particles. So beam of alpha particles is moving towards the gold foil. And after passing through the gold foil, you can see there are different observations. One over here, right? And some rays are striking this point, some at this point, some at this point. So you can see they scattered in different directions. Okay. So why they scatter in different direction? This is the question. And why there are like three beams close to each other. These two are very far from each other. And this is also very far from all the other beam of the alpha particle passing through the gold foil. So this is the question. Okay. So in the setup, you can see we have beam of alpha particle that strikes on a gold foil. There is a fluorescence screen, right? And why we are using fluorescence screen? To detect alpha particle. And fluorescence screen means it is just like photographic plate. And you know that when you click a photo, or like when we take X-ray, so we got some marks on the X-ray plate, right? Some region is black, some region is white. The bone area is white and the other area is black, dark. So in the same way, when alpha particle passes through the fluorescence screen, so it leaves its traces on it, right? And with the help of the glow, we can identify that something is passing through this point. Okay. They will not ask about it, that define fluorescence screen, what is fluorescence screen. This is not important for us. That's why you can see only steps are given. Important thing is the observation taken by the experiment, results deduced by the experiment. Those things are important. And we are going to discuss about that also. So as we already observe in the diagram, that most of the alpha particles are moving in a straight line over here. and very few of them is scattered at large angle in different direction. Okay, and maybe some of them completely bounce back. Okay, so if we talk about observations, so these are observations. So in this observation you can see most of alpha particles were able to pass undeviated. Okay, so this is the first observation. And as we discuss in the diagram, that most of alpha particles are over here. So they pass without any deviation. Okay, so this is the first observation. And you can also see in the flat diagram, like over here, these are moving without any deviation in a straight line, most of it. And the second thing is, very few of them deflected at large angle. Okay, and we also discuss the same thing in the diagram, very few of them deflected at large angle. And the third point is, very few of them bounced back. So these are three different observations taken from this experiment, Rutherford or Goldfoil experiment. Okay, very simple observation. You can also see in the diagram. They will not ask about to draw the diagram. Diagram is not important to draw, so don't worry about it. The only important thing about this experiment is on this slide. They will ask about observation. They will ask about deduction. They will ask about reasons. So these three things are important for this topic only. Okay, they will not ask about the process. They will not ask about the diagram to draw in your paper. They will not ask about the components, that why we are using fluorescence, not any other, because this is already like a experiment that is already performed, right? And we are only like studying the topic, that how this experiment was performed at that time and how we got these results and the structure of an atom. Okay, so that's why we are not going to discuss about the reasons that why we use this or that. So these are the observations. Okay, any question, any confusion till now in observations?
No, sir. No,
Okay,
sir.
so this is very simple. And if we talk about the detection, right? So what we actually get from these observations, so we can say that most of the atom is empty. Okay, if we link point number one with the observation of point number one, so most of alpha particles were able to pass undeviated, and the reason is that atom is mostly empty. Okay, so that's why most of alpha particles can easily pass without any deviation. Okay, because empty atom is mostly empty. Just like in the diagram, in the plane diagram, you can see there are so many blank space given in the diagram. Over here, you can see white area is completely blank. Right, so you can see so many area of this atom is completely blank. Now, if we consider the second point, so the second point is a very small and dense positively charged nucleus exists in center. Okay, so how we get to know that there is a positively charged nucleus in the center? Okay, so this is very simple. You can find out in the reason. So if you check reason number 2 over here, so in reason number 2 it is mentioned, those which approached near the nucleus deflected due to repulsion. Okay, because alpha particle is already positive. So when positive particles are moving towards the gold foil, and the beam of alpha particle is completely bounced back. So back means there is repulsion. And we know, just like the magnet, same poles repel each other. So if we have positive, positive, so they repel each other. Okay, so that's why the positive beam of alpha particle is repelled by the positive nucleus. And that's why we get to know that why nucleus is positive, because it repels the alpha beam. And definitely to repel the alpha beam, nucleus must have positive charge. That otherwise it will be not possible for the nucleus. Let's suppose if nucleus have negative charge, so it will attract alpha particles because alpha particles are positive. But nucleus like repel positive charge. It means both have same type of charge, and we already know alpha particles are positive, so definitely nucleus is also positive. That's why they are going to repel each other. So this is the reason that how we get to know that nucleus is positive. Then we have a third point. Third point is electrons move around the nucleus, right? So electrons moves around the nucleus. You can check reason number 3. Those which approach head on to the nucleus bounce back due to repulsion. So these are the reasons. And definitely those alpha particles which are moving through the blank area of the atom, so they can easily pass through that part because there are electrons revolving over there, and definitely electrons can attract alpha particle. So that's why they allow alpha particles to easily pass through that specific area. Okay. Any question?
No, sir.
No, sir.
Okay.
No, sir.
Okay, good. So, if you have no questions, so I will share these all file in the group after the class, so you can like note down after the class, no worries, because it is like already a prepared file. So, this is the scenario, right? This is also the topic of the nuclear physics. And just like in periodic table in chemistry, I hope you know about the periodic table. So in periodic table, you know, there are so many elements in the periodic table given, right? And if we talk about the elements in the periodic table, if we take example, there are two numbers given like in superscript and in the subscript of the element. So there is a picture attached also. For example, we have helium, right? So there is a number in subscript, there is a number in superscript. So the number given in the subscript is called atomic number, and the number in the superscript is called atomic mass or mass number, right? So basically, atomic number shows you the number of protons in the nucleus. So number of protons is also called, or it can also be represented by atomic number, right?
And sir, the number of protons is equal to the number of electrons.
Yes. So this is the first thing like we can observe from this picture of the element. And right now, if we talk about this example, so in this example, we have two protons, right? And then we have the second mass number. So mass number is also known as atomic mass. Both makes the same sense. And it actually represents you the number of nucleons. So it represents you the number of nucleons, and these nucleons are actually the sum of proton and neutron. Proton plus neutron, right? And if you need to find out the number of neutrons, so you can subtract them. It is already mentioned over here. If you need to find out the number of neutrons, so you can subtract atomic number from the mass number. You will get number of neutrons. Okay. And one more thing you mentioned that if we have two number of protons, so definitely there will be two number of electrons. So if we are taking a neutral body, Neutral body means there is like not a positive charge on it, there is no negative charge on it. If we are taking a neutral body, so on a neutral body, it is also mentioned in a neutral atom, the number of proton, it means the positively charged particles, are equal to the number of electrons, right? So you can see these two elements are absolutely equal to each other in neutral atom. Okay. In nuclear physics, we only going to discuss about the neutral particles, so don't worry about it. In electricity chapter, when we start electricity chapter, so in that chapter, we are going to discuss about these charged bodies, right? So don't worry about it that how to solve charged particles. They will not ask about charged particle in nuclear physics, okay? They will ask about the charged particle in electricity section, okay? So this is the concept of the atomic number and atomic mass. Secondly, we discuss about the Rutherford experiment also, or the gold foil experiment. So these are the two things we discuss. And you can see there is a statement of Rutherford attached with it also. In a lecture, Rutherford delivered at Cambridge University, he said, "It was quite the most incredible event that has ever happened to me in my life. It was almost as incredible as if you fired a 15-inch shell at a piece of tissue paper and it came back." So right now we are like only studying about the previous discoveries and the previous invention. If you compare your time with the time of Rutherford, so definitely at that time we like not living in the era of technology. Right now we have all the technology already discovered, already invented. So we already have different products that is absolutely like designed by the scientists and the engineers. But at that time they are working on it to discover the things, to invent the things. So at that time, if you perform this experiment at that time, so it will be like, you can see it is mentioned, if you fire a 15-inch shell at a piece of tissue paper, you know, it can easily pass through the tissue paper, but it bounce back from the tissue paper. So this experiment is exactly like the same when he performed for the first time and when he observed the result. So it was like there is a 15-inch shell strikes the tissue paper and it bounced back. So in the same way, when he observes the alpha particles are striking the gold foil, you know that aluminium foil is very thick, thin, and same if we consider the gold foil. So both are very thin, right? And we know we can easily like tear that gold foil or aluminium foil. And if you like strike a common pin on it, so that also penetrates into that foil. But the alpha particles are striking that foil and coming back from that foil. So that is a completely different observation at that time of discovery. So this is the concept of Rutherford.
Okay, sir, should we rejoin?
Yes, you may rejoin. So then we will discuss some other topics related to the structure of atom. Basically, structure of atom is a very short topic, and inshallah we are going to end up that chapter in today's class because that is very simple, and you can see topics are very familiar. You already know about them. Okay.